Hey everybody, it's video notes 9C part 1. So we're going to do this part in 2 sections, and here's the first. So here's the objective we're going to cover. You're going to be able to identify limiting reactants, theoretical yields, and then eventually calculate percent yields. So remember tricycles? So remember all bears need tricycles. So if we had 6 wheels and 12 frames, what would we be able to do? Okay. So one of these two, the 6 wheels and the 12 frames, are both reactants, right? Reactants and reactants. And so we could figure out, well, if I have 6 wheels and I multiply and I find out that they need 3 wheels for every 1 frame, then I will be able to use up 2 frames. I would need 2 frames, all right? But look, I have 12 frames available. So what does that mean? That means that the 6 wheels are the limiting reactant. Limit how many tricycles we get. 6 wheels are the limiting reactant because we'll use up the 6 wheels and only use up 2 frames, and then we have 10 frames left over. And so that means that the limiting reactant is the wheels, 6 wheels, and the 12 frames is the excess reactant. All right, so what's a theoretical yield? So theoretical yield is how many tricycles we can get, how much product we can get from our limiting reactant. So we start with our limiting reactant and we say, well, we need 3 wheels for every 1 tricycle, and we find out that we'll be able to make 2 tricycles. So this is called a theoretical yield because it comes from using up all of our limiting reactant. Okay, so we'll be able to get 2 tricycles for those 2 bears that need them. All right, so remember the cookie recipe? Well, here's the cookie recipe. If you had 1 large egg and 2 cups of morsels with plenty of everything else, how many cookies can you make? We have to figure out, this is a reactant and this is a reactant. We have to figure out which reactant is going to limit the amount of product we get. So I'm going to start with the 1 large egg, all right, 1 egg, and I'm going to say, okay, the recipe says I need 2 eggs for every 2 cups of morsels. So morsels. All right, so I find out that I will only use up 1 cup of morsels if I have 1 egg. So 1 egg is going to use up 1 cup of morsels, but I have 2 cups of morsels. So that means that the egg is the limiting. Egg limits how much product we get, how many cookies we get. Okay, so that means egg is the limiting reactant. So 1 egg is the limiting reactant. We're going to actually have a whole cup of morsels left over because we're only going to use up 1 cup of the 2 that we have. So then to figure out how many cookies we're going to make, we'd have to use our limiting reactant, the 1 egg, times we need 2 eggs for every 1 batch of cookies. Okay, and then for every 1 batch of cookies we make, we get 60 cookies. All right, so if we only have 1 egg, then that's times 1 divided by 2 times 60 is going to be 30 cookies. That's how many cookies we're going to get theoretically. So that's our theoretical yield. And our theoretical yield is the amount of product we get from our limiting reactant. Okay. So, whoa, look at this. This looks like hot dogs, right? So the product is a hot dog. All right. What is the limiting reactant here? So we have 5 dogs and 4 buns. All right. And so the limiting reactant is the number of buns because all of the buns will get used up and there'll be 1 hot dog left over. So the limiting reactant is buns. Theoretical yield is 4 hot dogs. So how do you figure out a theoretical yield? Use your limiting reactant. How do you figure out your limiting reactant? Well, we can do it this way. We can say we have 4 buns times 1 bun for 1 dog, and then we find out that we need 4 hot dogs, 4 dogs. All right, and so if we have 4 buns, we'll only be able to use 4 dogs. How many dogs do we have? We have 5. So buns limit the reaction. Buns are limiting. All right. And so what's our theoretical yield? Our theoretical yield is how many we'll get when we use up our limiting reactant. So 4 hot dogs is our theoretical yield. Theoretical yields. All right, so now let's get down to some chemistry, right? So go ahead and write these definitions down. A limiting reactant, sometimes called reagent, and sometimes I just say LR, is the reactant that gets used up first, and it controls how much product you will be able to get. The excess reactant is what's left over and doesn't get used. So if N2 are the green and H2 are the tan, and the reaction is 1 part N2 for every 3 parts H2 gives us 2 parts NH3. Okay, so this will get used up and we'll use up 1, 2, 3 of those. That'll get used up and we'll use up 1, 2, 3 of those. So the limiting reactant is the H2 because, as you can see, limiting reactant, as you can see, all of the H2 gets used up and there's extra N2 left over. Okay, so the limiting reactant is the one that gets used up to make product, and the excess reactant is what's left over. Okay, let's look at this one. After you figure out the limiting reactant, you use it to figure out the rest of the calculations. So, and when do you do a limiting reactant problem is when you have 2 amounts of reactants. So we have 1, 2, 3, 4, 5, 6 blue particles and 2 red particles. Okay, so it looks like we need to use up 2 blues, 2 H2s, for every 1 O2 particle to make 2 H2Os. All right, so one of those is going to use up 2 of these. All right, and then one of those is going to use up 2 of these. So that means we have 2 blues left over. So it's the limiting reactant is oxygen. Limiting reactant. Why? Because, as you can tell, all the oxygen gets turned into water, but some of the hydrogen still stays hydrogen, right? That's extra hydrogen left over. Okay, so if we wanted to figure out how much product we should get, we'd have to use oxygen. So 2 parts O2 times, it looks like we need 1 part O2 for over 2 H2Os is going to give us 4 H2O parts. All right, now we're going to call these moles, but right now they're just particles. So this is our theoretical yield, 1, 2, 3, 4. Okay. All right, so let's now take it really to chemistry, really to chemistry, and start using a balanced chemical equation and some actual grams. All right, so 20 grams given 20.0 grams of mercury and 5.00 grams of oxygen. And here's what I want you to notice. Mercury's here, oxygen's here, 2 reactants. 2 reactants given. Reactant amounts given. So that's a clue that I got to do a limiting reactant problem. Okay. So here's how you do a limiting reactant problem. You pick one, either one. All right. I'm going to pick mercury because it's first. I don't know why. All right. And here's what I got to do. I got to say if all my mercury gets used up, how much oxygen is going to get used? So I have to change grams of mercury into moles of mercury, because then I can change moles of mercury into moles of oxygen to see how much oxygen is going to get used up. But then I want to change my moles of oxygen into grams of oxygen, because then I can compare it to what I have. So anytime it's moles and grams of the same chemical, one goes with moles, and I go to the periodic table to get the grams. All right, anytime it's moles of one kind and moles of another, I use the coefficient. So front of the oxygen is a 1, front of the mercury is a 2. And then, anytime it's grams and moles of the same chemical, one goes with moles, and the periodic table goes with grams. If I do this math, I find out that there's 23.19 grams of oxygen. Okay, what does that mean? That means if all my mercury gets used up, then this is how much oxygen I need. So this is how much oxygen is needed to use up all the mercury. But we only have 5 grams of oxygen only. All right, so what does that mean? It means oxygen, oops, wait, I lied. I did all this math here. And it's not really 23.19, it's 1.595. Okay, grams of O2. All right, so this is how much oxygen is needed, 1.595 grams needed. And I have 5 grams of oxygen. Wow, I have a lot more oxygen than I need to use up all my mercury. So what does that mean? It means mercury is the limiting reactant, because it will get used up and O2 will be left over. All right, so that's the limiting reactant. State the limiting reactant. Okay, and the limiting reactant is mercury. Limiting reactant is Hg. Hg is the limiting reactant. Okay, second part of this says calculate the maximum amount that can be theoretically formed. So once I know mercury is limiting, I use mercury, which is limiting, and now I got to figure out how much product I'm going to get. So I'm going to be using pretty much the same setup. Change it to moles because then you can use the mole ratio. This time I'm going to say I want 1 mole of mercury, 2 moles of mercury coefficient for every 2 moles of product this time, because the theoretical yield is the amount of product, and then 1 mole of mercury oxide for every 232.59 grams of oxygen. Okay, I just realized that this is wrong. It's 216.59. You hear my dogs barking? They are barking away. Okay, I know I got it wrong, but I fixed it. 20 divided by 200.59 times 216.59 is 21.60 grams of mercury oxide is the theoretical yield. Okay, let me put this right up there. Theoretical yield. Because if everything works perfectly, my limiting reactant tells me that I'll get 21.60 grams of mercury oxide. Okay, let's keep going. So here, I just did a problem, but here are some of the steps that you can use. So you can write these steps down and see if you're doing them along the way. So first, decide what's given and what you're trying to find. And then if you're given 2 reactants, then you have to find the limiting reactant. That's part of the problem. Pick one reactant and change it to the other using the periodic table for grams and the mole ratio coefficients. Compare and think about what it means. What it means. Think about what it means. All right. Then once you know what the limiting reactant is, use the limiting reactant to find theoretical yields. And this is going to be in part 2, but use the actual yield and theoretical yield to find percent yield. Okay. So here we have 90 given 90 grams of FeCl3 and 52 grams of H2S. So look, this is a reactant, this is a reactant. So given 2 reactants, so this means we have to do a limiting reactant problem. LR needed. Okay, all right. And then also we'll find theoretical yield. So to find the limiting reactant, we pick one. All right, I'm going to pick 52.0 grams of H2S. So what do I want to change it to? Well, I want to change it to the other reactant to see how much gets used up. I'm going to use 38.09 grams. Periodic table for H2S, 1 mole H2S times, now we use the mole ratio, moles H2S. Let me see, 3. And then for every 2 moles of FeCl3. Okay. Then 1 mole of FeCl3 for every 162.2 grams of FeCl3. Where did I get that? Periodic table. And I find out that 147.64 grams of FeCl3 are needed. Okay, well, let's check. I need 147 grams of FeCl3 to use up all my H2S. All right. I only have 90 grams of FeCl3. So what does that mean? That means that FeCl3 is the limiting reactant because I don't have enough FeCl3 to use up all my H2S. So that means the FeCl3 will run out first. Okay, so that's half the battle is finding the limiting reactant. Once we know it, we use it. 90.0 grams of FeCl3 can be used to find our HCl, which is product. So then I would say 162.2 grams FeCl3. Where did I get that? Periodic table. 1 mole FeCl3. All right, now I'm going to do the mole ratio. So 2 mole FeCl3 on the bottom because the coefficient's 2. And then 6 moles of HCl on the top. Why did I pick HCl? Because that's what's asked about in the problem. 1 mole of HCl has a mass of 36.46 grams HCl. So once I do this math, I find out that 60.69 grams of HCl can form. That's a theoretical yield. 60.69 grams HCl is the theoretical yield. All right, we're getting closer to the end of part 1. All right, so we have given iron oxide and other given. So look, we're given 2 reactants, Al, this and this. So we know it's a limiting reactant problem. So you pick one. All right, I'm going to pick 10.325 grams of FeO. All right, I'm going to change that into aluminum, 71.85 grams FeO. How do I know? Because it's a periodic table, and that's for 1 mole of FeO. All right, and then for every 3 moles of FeO, where'd I get the 3 coefficient? Then I need to use up 2 moles of aluminum. All right, but I don't measure in moles, I measure in grams. So for every 1 mole of aluminum, it's 26.98 grams of aluminum. Okay, so I do the math for that, and I find out 2.58 grams of aluminum. What does that mean? That's how much is needed. So then I check back. I'm like, oh, I have 5.7 grams, but I'm only going to use up 2.58. That means there's going to be extra aluminum if I use all my iron oxide. So FeO is the limiting reactant. FeO is limiting. Once I find out FeO is limiting, to find the mass of iron that should be produced, product should be produced, theoretical yield, I take my 10.325 grams of FeO and change it into moles because I can only change chemicals when they're in moles. All right, and I got that from the periodic table. And then now I say for every 3 moles of FeO, I will get 3 moles of iron. So that's like my cookies. How many cookies I'm going to get? 3 moles of cookies. But what does 3 moles of cookies mean? Well, it means 3 moles of Fe for every 55.85 grams of Fe from the periodic table. And I find out 8.026 grams of Fe is my theoretical yield. Okay, all right. So, I missed a review slide and I can't go back. But, so here's the objective again. Review, make sure you go to moles, go to moles, go to moles. All right, take care, peace out.